our first example today. Retrieve all employees who were born in 1970s. Yeah. We have several different ways. First, let us use the regular expression way. First, from our employee table in the company database, I posted. So you just download. So you can install, or you just look at the content of the file. So here we need to describe the pattern for this B date field. The regular expression, because here, first, we look at the date format in SQL. SQL, we need to use the SQL date format. All right? So that is the standard, okay? International standard. So not just the format we use in this country, because different countries, they use the date format differently. But SQL standard in the world, 4 digits, so Y year, okay, 4 year digits. Then dash 2 digits, month digit, then day, 2 day digits. So that's the date format, SQL date format, okay? So if you have 1 digit month or 1 digit day, you use 0. So, for example, 01. So, all right. So here, 1970s, the birthday, 1970s. So you can see the first 3 digits of the year, 197. But that 3 digits appear at the beginning of the date string. So we treat it as a string. So here we use the beginning of the string. Okay, so that's 197 appears at the beginning of the string. So that's the simple way we describe his regular expression. But some students usually use a different way. They do not use the regular expression. So here there is a way, alternative way. Still B date. B date. That's the field name in the employee table. Between 2 days, 7 days. So we know 7 days. What is the first date of the 1970s? So they select beginning and end. Beginning and end. Then between. So they use between operator. So there is a between operator for dates. For dates. Here, let me use that way. Okay. So B date between, between operator. That 2, you need to specify first and the second. First, single quote, 1970/01/01, right? January the 1st, the end, right? The last date of the 1970s, 1/9/7/9/12/31, right? So that some students, they use that way. It's also okay. All right. Just give you some example, a simple example here. Next example, retrieve all employees whose address contains a $sign. Here I want to show you how to escape special character, because $sign is a special character, right? That's the, you use to represent the end of string, that meaning. End of string meaning. So it's a special. So here, but contain a dollar sign, address contains a dollar. Here I just make this question. So you, yeah, not necessary. You know, it is true in the real data. In the real data, it may not be true. Okay, all right. So here I just make that question. Yeah. Now you need to escape that special dollar sign symbol. The question: how to escape it? How to escape it? Okay. Yeah. If you recall the Java way, in Java we also use the escape way, right? So here we use the same way to do the escaping as in Java. Yeah. Let me show you that. All right. Regular expression use double backslash, not single backslash. Okay. Yeah. In Java you also use double backslash. Okay. So you refer to a folder path because you need to use backslash. But when you specify backslash, it should be double backslash, not single backslash. The reason is this. Because that escape, that backslash sign is a special character. The backslash itself is an escape character. Now you want to escape it, okay? Escape that, so you backslash sign, all right. Then, use its literal meaning of the backslash, yeah, okay? Literal meaning, yeah. I mean, whatever that logic, here, you just use double backslash, okay? If you want to escape a special character, use that double, not single, yeah. All right, that dollar sign, so you escape it. Yeah. So use the literal meaning, yeah. All right, yeah. So that's this question, yeah. But there is another question, yeah, also, you need to know that you can sometimes you can do more efficient. That's the negation operator. Yeah. Here, retrieve all employees whose address does not, we need negation sometime, okay? Does not contain a dollar sign. Yeah. Negation. Yeah. So then, when you represent this pattern, sometimes people use the straightforward way. Yeah. Sometimes people tend to use the straightforward way. Yeah. But you can see sometimes the straightforward way pretty complicated. So if you use the complement way, yeah, not straightforward, complement way, yeah, so usually better. Yeah. Straightforward way, that is, if a string does not contain any dollar sign, yeah, how about you represent all the characters on non-dollar sign, right? So first you represent non-dollar sign. Yeah. It's okay. You can use that way. Non-dollar sign, that's the, normal way. Yeah. You can treat normal. How to represent a non-dollar sign pattern. Yeah. So here, let me try the straightforward way first. Yeah. Let you compare two different ways. Yeah. Negation way and normal way. Yeah. All right. Let's compare. Yeah. Non-dollar sign. All right. We just represent dollar sign. You know dollar sign, right? Yeah. Non-dollar sign. How about this notation? This is negation. Not. Okay. Not a dollar, double slash, backslash, dollar. Yeah. Is this non-dollar, right? Yeah. Non-dollar character. Any non-dollar character, you use this way. Okay. Now, you use this pattern to cover the whole string, right? Yeah. Because you do not allow any dollar sign in the string. So you should use this pattern to cover all the characters in the string. Yeah. All right. 0 or more, right? Or the, this instance, this pattern, this element, yeah. So in our description, we call this element. Repeat it. We want to repeat this element 0 or more times. So we use star, right? Yeah, 0, oh, sorry. Yeah, star means 0 or more times. All right, then, is it enough? Do you think, is it enough? Because you need to represent, we want to cover the whole string. We don't want to miss any place, right? If we cover all the string, when you start, it should be this pattern, right? Then at the end, no other patterns, right? So then you end it immediately, okay? So in this way, between the starting point and the end point, everything is covered by this pattern. That's the meaning, right? Everything is covered by this non-dollar character pattern. That's the logic. Here you can see, if you use the normal way, you need to do a lot of work. You need to consider a lot of things. Yeah. But if you use the negation way, then much easier. Okay? All right, here, does not contain dollar sign. Let's represent contain dollar sign, then not. That's so easy, right? Yeah. So the negation way, most of the times easier than the straightforward, normal way. Yeah. So here, negation way. You only need to add a not in front of that reg exp operator, not negation. How easy it is, right? Yeah. So when you apply your logic to represent some pattern, sometimes you need to use this not negation way. Yeah. So that, much easier. Okay? Yeah. All right. Good. So after this example, then our last example for this topic. Yeah. Last one. Challenging. A pretty challenging one. Okay? Yeah. So let me.
I have a question.
Oh, question?
Is the dollar sign a special character inside the angle brackets, or is it treated as a normal character?
Sorry, my volume is too low. Let me make my volume a little larger so I can hear what you said clearly. Yeah. Let me make my speaker volume a little larger. Can you repeat your question?
Yeah. Is the dollar sign a special character when it's inside the brackets?
Oh, yeah. Dollar sign is a special character anywhere, not necessarily inside bracket. Oh, you asked me if it's inside bracket, still special character. Yes, still special character. Oh, you're talking about the position, right? Yeah, okay, yeah, that's a good question. Yeah, that's a good question. Yeah, because you said only at the end it's a special. Yeah, all right. Yeah, this question. Good. Let me check it. Yeah, I need to do testing. Okay. Yeah. Good question. Yeah, good question. Because, you argue if it's not at the end, so then you. Yeah. So that's yeah. I don't remember if I tested, but I need to test it, okay? Then I'll give you an update. Yeah. Right. Okay, yeah. But actually, so you said that bracket, actually, right. Yeah. All right, good. Okay. Yeah. So I will test it. Yeah. So there it. Yeah. Because based on the logic, it could be separated. Yeah. If there is no confusion, so yeah. All right. Yeah. So Then the next question. Oh, yeah. So let me move to the next slide. Yeah. So we finish this slide. All right. So next slide. All right. Retrieve all employees whose address contains exact one dot. We know dot is a special character, okay? Yeah. But here, exact one dot, how do you represent it in regular expression? Yeah, think about that. Yeah. So here, by the logic, first we know we need to use that double backslash to escape that special character. So to represent that literal dot pattern, so double backslash. After that, how do you represent exact one dot? Yeah. So you have different ways to represent, right? Yeah. Yeah. If you look at our previous example, yeah. So the straightforward way, okay, yeah. Normal way, another negation way, yeah. Yeah. Straightforward way. Yeah. First, you need to represent that dot, yeah, contains one dot. Before that character, that dot character, you have no dot. So other character must be non-dot. That's before. Yeah. You can do it. Yeah. Then after that dot character, all the other characters must be non-dot. You can also do that, right? Yeah. Yeah. Here I do not write. Okay. Yeah. Yeah. Could be complicated, but doable. Okay. Doable. Yeah. Then negation way. Think about that negation way. Okay. All right. Negation way. Yeah. Because this kind of thinking, you know, so you can make your question much easier. Yeah. All right, so here I just write an address part. Okay. So where address part. Regular expression. All right. First, let's match that dollar sign. Okay, that's easy. How easy it is, right? Yeah, it contains, because if this is expression, this is true, it contains at least one dot sign. Then remaining, yeah, because you may cover too many cases. Yeah. So you need to exclude a string that contains more than one. Oh, let's say more than one, at least two, right? So you need to exclude all those strings containing at least two dots. Okay, two dots. All right. Yeah. How about this time and, right? Yeah, because after that you need to and. Yeah. And the second part, yeah, let me write the second line, still address, this time not, okay? Negation, not regular expression. Then you need to represent two dots. Okay. Because before the dot, anything is okay. So we do not need to write anything, right? So let's start with the first dot. Yeah. After that dot, non-dot character, yeah, so because you may remember, non-dot character could be repeated 0 or more times, right? 0 or more times, all right? After that, another dot character, another dot. Okay? Yeah. So this pattern catches those strings that contain at least 2 dots, right? Yeah. Because before this, anything is okay. Anything after that, anything is okay. Yeah. You know. So at least 2 dots. Then, not. We exclude it. Yeah. Then it's much easier than the first way. The first way, yeah, you can do it. You can still do it. Yeah. But you need to be very careful. Okay? Yeah. In the beginning and, you know, yeah, covering non-dots, you know. Yeah. You can do it. Yeah. 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 All right? Yeah. Yeah, actually not, yeah, probably not too hard, right? let us try that way, okay? Direct way, yeah. Yeah, okay? Yeah. Direct way, okay? All right. So the pattern. Yeah. First, you need to represent beginning of the string. After that beginning of the string, you have certain number of non-dot character, right? Non-dot. So, yeah. Non-dot character. Then you repeat it 0 or more times, right? Because including 0 time. Stop. Okay? After that, you need to match 1 dot. Okay? Yeah. After that 1 dot, then you need to match non-dot character 0 or more times, right? Then end of string, okay? Sorry, you're not backtick, okay? I should write it carefully. That's the single quote, not backtick, okay? Yeah, yeah, single quote. Yeah. So in this way, that's the, you know, direct way. Yeah, you can still do it. Yeah, not too bad, not too bad. Yeah, yeah. All right. So yeah, here just you know, give you plenty of examples. Yeah. So then you can practice in our first homework assignment. Yeah. Oh yeah. Oh, I remember one question one student asked in the last Zoom meeting, Wednesday, our last week. Yeah. One student asked me, oh yeah, a bit larger. If you look at the database, I posted the company.sql. So you open up and you look at the definition of the employee table. You can see, yeah, it uses F name and L name. All right? Yeah. So here it's we do our questions based on the given table. Okay? So yeah. So it's not a, you know, you imagine something, you know, yeah. So we use the same field names given in the example database. Yeah, yeah, column names. So then, could you run this in? Yes, we can. Yeah. So, you know, copy paste. We type. You know, that copy. So we put in the window. We'll run. You will see the result. Yeah. So when you work on our homework assignments, you can do experiments. So homework assignments, actually the first homework assignment, I want to give you 10 questions, all on the Microsoft North Wing, because here I assume, even if you haven't installed the software, yeah, you know, our MySQL, you know, anyway, even if you are not ready, because that one is online, right? The W3 schools. So Microsoft, that you can do experiments. You know, you go to W3 schools. So that's the first 10 questions. Yeah. But the second round, so probably I need to give you, you know, our own database questions. Yeah. But first, to give you a little more time, you need to, you know, get your environment ready. Yeah. All right. That's the, you know, last 2 questions. All right. Now, let's jump to our new party. All right. Last part of Module 2. some more database concepts. All right. The first concept, D.1, virtual tables. Yeah, from the name, yeah, it's not real tables, virtual tables. Yeah, so what's that? Yeah. So this concept also very useful. Yeah. View of a database, this concept. So we call it view. So here, we use this is the terminology. So this view is a special terminology in our database concept. Just like table, we know in our database concept, table is a special concept, right? Yeah. Here, the view, similar to table. View, yeah, so this view name. So that's the meaning, it's a virtual table. So not a real table, okay? It's a virtual table. So what's that? Yeah. Why we need it, this concept. Different users may require different perspectives on the same set of data. Yeah. Because in the real world applications, yeah, we have some original tables. Yeah. Original tables. Right? Yeah. And in the real world applications, yeah, so let me represent these as the original tables, okay? Yeah. But in the real world applications, most of the time, people use the data come from several tables, several original tables. Yeah. So not data directly from so the data need to do some special arrangement. Yeah. So not straightforward data. Yeah. Some special arrangement is needed. Yeah. For example, I will give you another database called a university database. Yeah. So in our second project, so we will work on another database, university. In that database, yeah, for example, there are 5 tables: a student table, course table, prerequisite table, yeah, grade table, right? Yeah, so there is another table, okay? All right. But that we treat these 5 tables as the original 5 tables. Yeah. But in the application, people need to use the data. You need to do some processing, do some special arrangement. For example, so there is an application. We want to get the transcript of the students. The transcript. There is no original table called a transcript. Okay? There is no original table called a transcript. So you need to combine, several, 3, let's say data from 3 original tables, and arrange them in a special format to generate that transcript table. Okay? Yeah. So here, here example, if for the university, that the database, if we use university database, all right? Yeah. The transcript table. Yeah. That's it's a derived data, not original data. Derived data. Okay? All right. Yeah. So you can display the result of the transcript table. Okay? Yeah. Yeah. All right. Yeah. But the question, yeah. So you need that view. You need that perspective. Okay? You need that. So our users need that special perspective. Yeah. Other than the transcript table, then our users may need other different ways to present the data, right? Other various ways to present the data, our users. Yeah. How do you manage those different perspectives of the data, right? Yeah. 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 So here, there is a special way here, virtual table. We can use virtual table to represent those different perspectives of the data based on the original tables. Okay, yeah, because they're not original tables. Yeah, it's an efficient way to handling data. Yeah, yeah, all right, yeah, yeah. Because so think about that. After we represent those perspectives, we want to store those perspectives. Yeah, yeah, because it takes a lot of effort. It takes a lot of effort to represent those perspectives, right? For example, transcript. You do the arrangement special way. You know, it takes, you know, quite some time. Yeah. But after that, do you want to store your effort, your work, right? Yeah. So you want to preserve your work. Yeah. You want to preserve your work. Yeah. But you don't want to store redundant data. Yeah. Because the data, if you store the data part, that's the redundant data, right? So you want to preserve your work, but you do not want to store the redundant data. How do you do it? Okay? How do you do it? Because you don't feel it's necessary to store the redundant data. Yeah. Yeah. You don't feel it's necessary to store the redundant data. Okay? Yeah. So the solution, yeah, you use this concept, virtual table concept. Yeah. All right. Virtual data. Yeah. You do not really store the data, but you store the way to generate the data. That's the idea. Okay? How to generate data? Yeah. So our, you know, SQL statement, yeah, our complex SQL statement that we use to generate it, we store that part. Yeah. All right. So no physical storage for the data. The data part, yeah. So we do not store the physical storage. Okay? Yeah. We'll save that part. Yeah. Derived from physical data. Yeah. So our virtual data, virtual table, virtual data derived from the physical data. Yeah. But on hard drive, it is not stored on hard drive. Okay? The generated data, you can see it is displayed on screen, but that part, that data is not stored on the hard drive. Not original data, so we do not store on hard drive. Okay, all right. So we can save storage space. Yeah, all right. Yeah. Could be stored physically if needed. Yes. Then, if you have some good reason you want to store the physically, yeah. So you can store it physically on a hard drive. Yeah. So you have that capability. Okay. The DBMS has that capability, but most of the time we don't need to do that. Okay, but in some very special situation, yeah, there you want to physically store it. Yeah, so you make it physical. Okay, so you make the virtual data to physical just by one more command. Okay, so you save your virtual table. Yeah, all right. Yeah. Oh, sorry. Yeah. Then the last thing about this, yeah. How to create a virtual table? So easy. You know how to create a table, right? Yeah. How to create a similar way. Yeah. 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 So when you create a table, a physical table, yeah. So use the create command, right? Yeah. Think about create. Yeah. The keyword create, yeah. Table, yeah. So you, yeah, here, yeah. Suppose use table, right? Yeah. Then your table name, okay? Yeah. So here, so that's your table name. Then the remaining SQL statement. Yeah. So there you create a view Yeah, here we call it view. Okay, I'll create a view, virtual table. You change table to view. That's simple, right? The remaining syntax exactly the same. Okay, create view. All right. So your view name. The remaining syntax exactly the same as the, table definition. Yeah, yeah. So that's simple. Yeah. Okay. Yeah. All right. Then, size of a database. Yeah. This we mean amount of space you occupied on hard drive. Yeah, because database, we need to store the data of the database on hard disk. So typically for a database, is there any limit for the database, the size of the database, right? Yeah, you may think about that. Yeah. So for that question, the general answer, a database can be of any size, okay? Yeah. And the complexity. Yeah. So that is no size limit, okay? Yeah. But we know our computer hard drive has a limit, right? Our computer hard drive has a limit. Yeah. Yeah. But inside the DBMS, there is no limit. Yeah. Definitely your resource always has a limit, right? Yeah. Your real world resource always has a limit. Yeah. Yeah. But if your resource is available, then the DBMS can handle databases of any sizes. Okay. Yeah. Very large sizes. Yeah. It's okay. Yeah. 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 All right. But some of the DBS may put a restriction. Okay. Yeah. Some MySQL, Oracle, those big players. Yeah. No limit. Okay. Yeah. No limit. Yeah. But for some small DBMSs, so there's a limit. Yeah. Here the Microsoft Access, 2 gigabytes limit. Okay. Yeah. 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 Because the reason for the limitation there pretty obvious, because the access is used for small business, home business, that kind of usage. Okay, so if the database is too large, too big, you need to move to different DBMS. Okay? You should not use the Microsoft Access. Okay, yeah. So that's the reason. It's not for large databases. Yeah. Yeah. Understanding query. So here, for this word query, we use this word a lot. Yeah. So the meaning here, 2 meanings. In narrow sense, yeah. Yeah. So data retrieval. Yeah. Narrow sense, query means data retrieval. Yeah. Yeah. Yeah, but people use it, in broader sense. Yeah. So sometimes that means any database access, including modified data, all called queries. Yeah. Also legal. Okay. Yeah. So we do database query. Yeah. We include, modify the data, insert new data, yeah, and delete the data even. Yeah. People can also call queries. Yeah. So no problem. Yeah. 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 All right. Yeah. So that's this part. Next part, D.2, integrity constraints in DBMS. Yeah. All right. Data integrity issue. Yeah. All right. certain conditions on data must be applied. So when we describe the data, so we want to, put some restrictions. Yeah. So that, set some rules for data integrity. Yeah. All right. Who will enforce those rules? Yes. So who will enforce those rules? Yeah. Depends. Yeah. So let's see the cases, two cases. Yeah. One, application programmers. Yeah. So we need to do a lot of work to enforce those data integrity rules. That's one case. Another, DBMS can do it. DBMS, has some internal mechanism to enforce data integrity. Yeah. Yeah. Both ways. Yeah. Usually, what DBMS can do, the relatively easy rules. Okay? Yeah, easy rules. Yeah. Application programmer, harder rules. Okay? Yeah. So if it's too complicated, yeah. So DBMS cannot handle. Okay? DBMS is not that smart. Okay? DBMS cannot handle. Yeah. So we need to write programs. Yeah. We need to write. Usually people use the, stored procedure. So usually, yeah, how to enforce. So we use, we need to write stored procedures, programs. Okay, to implement. Yeah, very complicated. Yeah, that we can do it. Okay. Yeah. All right. Yeah. Okay. Yeah, but for DBMS, so usually, yeah, we want to make it do as much as possible. Yeah, but it has a lot of limitation. Okay, a lot of limitation. Yeah, so it cannot do much. Yeah, it cannot do much. Yeah. Yeah. All right, here, so, yeah, specifically there are these types of integrity constraints we can do. Yeah. The first type, specifying a data type for each data. That's easy, right? Integer type, string type, date type, many other types. Yeah. So that kind of integrity constraint, DBMS can do it, enforce it easily. Yeah. Yeah. Straightforward. Yeah. Yeah. So this type, yeah, DBMS. That's its responsibility. Yeah. Another type called a referential integrity constraint. Yeah. That's something related to foreign key. Yeah. Later we will learn this concept, foreign key concept. Yeah. Yeah. So what's that? So yeah. So its meaning is pretty simple. So here, because we need to consider relationship between two tables. Yeah. The first table T1, the second table T2. But in the first table, there is one column. The data is used, referred to the column in the second table. But second table, this column must be a primary key. Primary key, okay? And this one, so we call it a foreign key. Yeah. So this case, yeah, so the constraint we call a referential integrity constraint. Referential, yeah. Yeah. Reference table. Yeah. This type, DBMS enforce. Okay. Yeah, a record in one file. One file means one table. Remember, I mentioned, in database concept, a file means a table. So one file must be related to records. One record that related to another file. Yeah. Specifically, that's the relationship. Yeah. All right, yeah. Then another constraint called a uniqueness constraint. Yeah, regarding the data. Yeah, because so here let's consider a table here. Yeah, so table. One table, we have many columns, right? Yeah, multiple columns. Yeah, yeah. But sometimes one particular column, the data in this particular column, we need a special property. That's the uniqueness property. Yeah. The data cannot be duplicated, so unique. Okay? The data must be unique. Okay? So two pieces of data cannot have the same value. That's the uniqueness requirement. Yeah. So that, if you need that requirement, you need to add a constraint, uniqueness constraint on it. Okay. Yeah. So we call this column the key. Yeah. Yeah. So this column can be used as the key column, key uniqueness. Yeah. So DBMS can enforce that easily. So easy, the DBMS can check if the data unique or not. Okay. So if you specify the uniqueness constraint, you just tell DBMS, you add uniqueness, unique, yeah, the keyword unique. Yeah. You append unique keyword in that column field. That DBMS enforces data uniqueness. Yeah. When you have a duplicate values in that column, DBMS reject it. Okay, DBMS, does not allow you to do that. Yeah. But the last integrity constraint, that's the business rules. That's the complex part. Yeah. Yeah. Complex one. The data must, satisfy a list of rules. Yeah. Yeah. The DBMS cannot handle that complexity. Okay. So if we are application programmers, we need to write a code to, going through all the rules, So you need to write the logic, okay, the programming logic, to implement all the business rules. Yeah. So that's the application programmers, our responsibility. This part, that's our responsibility. Okay, all right. Yeah. So that's this topic, integrity constraint topic. Yeah. All right. Then, our last topic, deep on 3, about stored procedure. How to use stored procedures, the benefits. Yeah. So we need more discussion on it. Yeah. All right. Yeah. Yeah. Database stored procedures. Yeah. Situation. Yeah. Yeah. So, under what situations should we use stored procedures? Yeah. All right. Resources are distributed on different machines. Yeah. I talked about this topic before. Yeah. Yeah. Because in our current IT industry, many web applications are very large, distributed globally. Yeah, think about distributed globally. Yeah, many. Yeah. So there are many servers in the world running the, spread in the world, running the web applications, right? Yeah, connected, yeah, things like that, connected. Yeah. Here, let's assume this, the center one, the data center, okay? Yeah. Data center. Yeah. So the large number of servers used to store, manage the business data. Yeah. All right. In that situation, Then there are many modules spread different places in the world, Yeah. So here let's treat as all these as web servers. Okay. Yeah. Outside. These are the web servers. Okay. All right. Yeah. So they share the same set of business data. Yeah. Same set of business data. Yeah. All right. Yeah, web server. And these web servers, because they need to implement different services. Yeah, yeah. All these web servers, could be for different services, for different services. Okay? Yeah, various services. Yeah. AI, data, science, a lot of different services, right? Yeah. And then those, different teams, yeah, because this big, huge web application, many different technology teams are working for this big project. Okay? Yeah. And those teams, different teams, they have different expertise. Yeah. They can apply to develop different services for this big project. Okay? Yeah. And for different services, they prefer different programming languages, right? Yeah. Some services, yeah, so people want to use Python, yeah, because a lot of AI related tasks, or data science related tasks, okay, things like that. So, they like to use Python to write the service code. Yeah. Then, for different, teams, they use different programming languages. Yeah. The program they feel the best to write the code. Yeah. So that happens frequently. Okay. All right. So then, under that situation, but they want to access the same database. Yeah. SQL, database. All right. Yeah. In that situation, running. Yeah. So that there is some way. Yeah. So if you have some data-related, heavily data-related tasks. So heavily data-related tasks, you may like to use the, database program modules, SQL, to write those modules. Okay? Yeah. As stored procedure. Yeah. Because in that way you have other advantage, you have benefit. So let me talk. I do not have much time. Yeah, 7 minutes. Yeah, let me use just about 5 minutes. Yeah, if I cannot stop, complete, we will complete next time. Yeah. All right. So the stored procedures, there are two types. Yeah. The first type, so we call it procedure, but no explicit output. You only do data processing, but you do not generate output. Okay, like a void function. Void function, no output, but you process the data, you change the data, you manipulate the data. Okay, so that kind of functions we call a procedure. The second type we just call functions. So we separate. Okay? When you see functions, that means you expect return the data. Okay? Output, data return. Yeah. When you see procedure, yeah, you know, doing data processing, yeah. No data return, yeah. No output, yeah. Void. Yeah. So in SQL, so that's the, you know, store procedure SQL way. All right. Properties. Yeah. Store and execute by the DBMS at a database server. Yeah. So because those store procedures are running in the database server. Yeah. Yeah. All right. Yeah. Create it in DBMS or in application programs. Yeah. So any application programmer, if you have that support, okay, yeah, you need to have that support. Yeah. Yeah. MySQL, Oracle, yeah. So which DBMS you are using? Yeah. When you have that support, then you can write your application programs to create stored procedures. Yeah. Remotely. Yeah. So you do not need to go to that data center to create, right? Yeah, no, not necessary. Yeah. Remotely, yeah. Remote location. Yeah. So you write the code, yeah, execute it. Suppose you have the permission, right? You need to have the privilege to do it. Yeah. We assume you have all those things, so you can do it. Okay? Yeah. All right. So then, called in application, we need to use it, right? When we do data process, we need to call it. So called in our applications. So suppose, so you have the, you know, privilege to access that part of data. Then you execute command, you send your SQL call command to your remote DBMS. So you get, you know, return the result. Yeah. So if you, yeah. All right. So then the benefit. Yeah, I need to say something about the benefit. Yeah. Circumstances using stored procedure. Typical cases. A database program is needed for several applications. Yeah. So here we assume, you know, several services. They need to, you know, call the same database program. Yeah. Okay. Yeah. In that case, the applications could use different programming language. Yeah. So, yeah. So, yeah. Because, you know, for different services, yeah. Sometimes this programming language is good for this particular service. That one is good for that particular service. Yeah. 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 Many. And people don't want to put a restriction. Yeah. People don't want to, yeah, especially for that huge web application distributed. People don't want to make the entire web application, you can only use one single programming language. No, that's too restricted. Yeah. Too limited. Yeah. No. Yeah. So you can use, you know, any programming language you like. All right. Yeah. Reduce duplication effort. That's another big advantage. Yeah. Let me finish. This is my last question today. So after I finish this one, then we, you know, we're done today. Yeah. So here, that is the stored procedure. Reduce the duplication effort. Okay. Yeah. That's very easy. Yeah, yeah. So here, let me use a few examples. Suppose we have a Java service. Yeah, I mean the service we need to use Java to write the code. Okay. Another type of group of service we need to use PHP to write code. Okay. All right. So then, you know, some Microsoft, because some services they need to use a lot of Microsoft existing services. Then they like to use the C# to write, right? Yeah, because it's better communication. Yeah, they use C#. They can call, you know, various Microsoft, you know, services easily, right? Yeah. So C#. Then Python, right? AI, data science related services, they want to use Python to write the code. Okay. Oh yeah. So then, reduce duplication of effort. So then, you only need to write, stored procedure once. Yeah. So you do not need to write a Java version. So you only write a SQL version. Okay. You only write a SQL version. You do not need to write a Java version, write a PHP version, write a C# version, write a Python version. No, right? Only one SQL version. Okay. All other programming languages, you can access the same set of stored procedures in SQL. Okay. Only do once for all. Okay. That's so efficient, right? Easy to maintain, right? Easy to maintain. If in all these programming languages, when you change something, you need to change all the versions, right? Yeah, easy to maintain. Yeah. All right, let me stop right here. I run out of time.